Okay. Okay, my name is Dr. YM10. So you see my office number and as well as my contact email address. Okay. Now you see. Let me talk about the assessment components. So this subject is consists of two major components. First of all, it's about the continuous assessment part. So for the continuous assessment part, we should share 50% of the total marks. And then we also have the examination. For the examination is another 50%. Okay. So for the continuous assessment, we have 20% for the assignments, 20% for the group projects, and 10% for the quiz. Okay. Remember that for this subject, we have two lecturers. One is me, you may call me YM, and also we have another lecturer, Dr. Jackie Ting. Okay, you'll see him in the next lesson. Okay. There are two lecturers for this subject. Okay, so we will share half and half. That means 50% is for me, and then another 50% is from the Dr. Jackie Ting. Okay. So what we are going to talk about for this subject, this subject is about the business intelligence and the data mining. So we'll talk about some of the theoretical background about the business intelligence. We'll also talk about some of the theory on the business intelligence and data mining approach. For example, I remember that some of the students told me that you have learned some of the data mining approach, for example, the association rules, the clustering method. So I'm not going to cover these two major data mining approach. What we are talking about is about some more related to the intelligence-based approach, which will be related to the neural network. I think most of you has already heard about the neural network, which is usually used in the artificial intelligence. Okay, so these are the subject syllabus. Okay, we have some introduction first about the business intelligence and data mining. As I just mentioned, with some of the data mining approaches about the association rules and clustering, and because another subject has already covered these two topics, so I'm not going to go through in details for these two approach. And then I'll replace it by another more intelligent approach, which will be covered in the coming lectures. Okay, so let me show you the teaching timetable for this subject. Okay, so actually you can find the teaching materials on the Blackboard as well as the teaching timetable. So you can take a look on the teaching timetable. So this is the first lesson. Okay, this is the first lesson. Okay, we teach by me, and this subject in this lecture I'll talk about the first rule-based reasoning approach, and then in the next lesson is taught by Dr. Jackie Ting. Okay, he will talk about some fundamental big data, and in the third lesson is also taught by Dr. Jackie Ting, and then in the fourth lesson will teach by me. I'll touch you about the decision tree as well as the neural network, and then for the fifth lesson is taught by Dr. Jackie Ting again. Okay, so remember that in the coming 5 lessons, okay, we'll conduct the online teaching by using Microsoft Teams. Okay, so and then we have 2 weeks break from at the end of March. Okay, so that means there's no lesson at the end of March. We have 2 weeks break. Okay, and then how about the arrangement after break? We don't know yet. I don't know yet. Okay, so we need to wait for the university arrangement. So the lessons after the break will be confirmed later. Okay, I'll let you know what is our plan later. I'll post it on the Blackboard. Okay, so since we cannot conduct face-to-face teaching. Okay, therefore I have arranged the lab session, the case study session, project presentation session after the break. Okay, so that means in these 5 weeks, I'll go through all the lecture first, and then after the break, we'll conduct some lab session and a case study session. Okay, as I mentioned, as we have mentioned, for the assessment components, we have 20% for the individual assessment. Okay, so for me, I have 10%, and Dr. Jackie Teng has another 10%. Okay, so for the assignments, actually, I have arranged 2 assignments for you. Okay, you have to submit within 1 week. I will let you know how you submit the assignment later. Okay, and then we have the group project. Okay, 10% from Dr. Jackie Teng and 10% from me. For my group project, you need to do the project presentation. Okay, after the break, but because we still don't know the arrangement after the break, so I'll let you know how we arrange the group project later. Okay, I'll tell you during my next lecture. Okay, and then another 5% is from the another 10% is related to your test. So the test is arranged on 18th of May. Okay, in the last week of your teaching timetable. Okay, I don't know, can we conduct any face-to-face teaching at that time? Okay, we'll let you know what's our arrangement later. Okay, and then finally, it's about the examination. Okay, we have 50% for the examination. So please remember that we have 2 lecturers, and then we share our marks equally. Okay, that means 50% from me and 50% from Dr. Jackie Teng. Okay. Okay. Now I'll show you the PowerPoint for. I've already go through the course outline, the teaching timetable, and then I'll show you the first PowerPoint, which is about the introduction to the business intelligence and data mining. Okay, I don't know whether you have any question. Okay, so if you have any question, you can leave a message on the right hand side. Okay, because there's a chat box on the right hand side. So if you have any question, you can leave me a message. Okay, so we start the introduction to the business intelligence and data mining. So do you know what is business intelligence? So actually, the term business intelligence has been can be found in many years ago, since 1990. So that is already 20 years ago. Okay, we have the business intelligence because we would like to apply the business intelligence in many situations, especially in different kinds of business. Okay, so the business intelligence is defined as a set of concepts or method or process which want to improve the decision. Okay, so why we have the decision? Because in many situations, especially in the business, if you are the manager of the business, there are many situations that you need to make your decision. Okay, that's why we have to apply the business intelligence. Okay, so in order to apply the business intelligence, we have to use some of the business intelligence solutions or tools. So these kinds of business intelligence tools are very important because when you make the decision, you may need to have some data. Okay, after you got some data, you need to make use of this data to make the right decision. How can we make the right decision? Then we have to apply some of the business intelligence tools in order to enhance some of the accuracies of your decision making. Okay, so this business intelligence solution or tools or this kinds of approach is very important because it can enhance the speed of the report generation. Okay, it can also increase the accuracy of your content. It also improves the degree of user-friendly format because usually when you got some data, it's usually some kinds of raw data. Okay, this is very difficult for you to find out the pattern of this raw data. So that's why you need to apply the business intelligence solution or tools to improve the degree of user-friendly format so that you can understand the data very easily. For example, you can using the graphical format or histogram or pie chart and so on. Okay, and then we can enable the information to be expressed to appropriate individuals. So that's why we have to apply some of the business intelligence tools. Okay, so why do we need the business intelligence? As mentioned, in many business, we need to make some decision. Okay, so in order to make the decision, for example, in the customer relationship, okay, we will apply the customer relationship management. For example, we want to have a better relationship with different customer. We need to understand the customer behavior, understand what the need of the customer. Then we need to make some decision. So this is why we need to apply the BI. Okay, and then for example, another situation like the supply chain management, we need to make sure that the supply chain is smoothly. We can supply the product to the other location or supply the product to the other supplier, distribute to the distributor, and so on. So these kinds of things need to have a very good management approach. Or how can we distribute to them on time? Okay, make sure that we can save the cost and so on. So we need to have some decision making. So that why we need to make the decision, because usually in the business we need to think about the manager. If you are the manager, you in most of the time you need to make the decision. There are three different basis roles for making the decision. So like first of all is the interpersonal roles. Okay, you know that as a manager, you think about if you are a manager, you need to talk with different customers, you need to talk with different partners and so on. So that one of the major roles for the manager is the interpersonal roles. And then second is about the informational roles. Okay, so for the informational roles, you need to get different data or information and so on. And then finally, you have to make the decision based on these kinds of information, so that the manager have these three basic roles: interpersonal, informational, and decisional roles. Okay, so how the business intelligence works? Okay, so this is the overall diagram related to the business intelligence. So at the middle, you can see that this is a data warehouse. Okay, so the data warehouse is very important because when you're making any decision, you need to have some information. You cannot make decision without any information. So that data or information is very important. So when we talk about the business intelligence, first of all, we need to have some, we have the data warehouse to store all the information, store all the data. Okay, so but how can we get all this information or data? We need to have some system or some tools to collect this data. Okay, for example, we have the ERP system, enterprise resources planning system. We have the CRM system, customer relationship management system. we have SCM, supply chain management system. Okay, so we can make use of this system or sensor to collect all this data and then store this data in the warehouse. Okay, just like your Apple Watch. Okay, the Apple Watch will also collect your data. Okay, so by using this system or sensor, then we can collect the data from the customer, from the resources or human beings and so on. Okay, and then we store all this data in the data warehouse. But after we store all this information in the data warehouse, how can we present this information, or how can we make decision based on this information? This is very difficult for the manager to make the decision, because you know that data has a large amount of data. We need to do something before we can making correct decision. Therefore, we need to using the business intelligence tools, as just mentioned, to present the data graphically or tidy up those data, or using the data mining approach to come up with some conclusion before making any decision, so that we have the data in, store the data in the data warehouse, and then finally is the data out by presenting this data graphically or using data mining approach. And then based on this information, then the manager can make a correct decision. So this is the general idea for the business intelligence. Okay, so when we talk about the organization of the business intelligence, we have the large data warehouse we store in the company, but for each department may also have their own data warehouse to store different information, like the sales data warehouse, finance data warehouse, inventory or shipping warehouse, and so on. So we have the data warehouse in the enterprise level as well as the departmental level. Okay, so how can we present? As mentioned, we need to present those data in a more systematic approach. So how can we present this data in more systematic approach? There are different business intelligence tools we can use. For example, we have the digital dashboards. Okay, just like the figures on the left-hand side, you will see that, okay, these are some of the raw data. Okay, this raw data is very difficult to for the managers to make any decision. But if we tidy up those data and then present those data, it's just like on the right-hand side using the digital dashboards, then you see that, okay, wow, it looks much better, right? Okay, it's much easier for the managers to make a appropriate decision. Okay, as mentioned, we can make use of the dashboard to present the data, or actually, we will call this kind of approach is called data visualization. Okay, remember when you talk about the business intelligence, we need to make use of the data, and then by making use of the data to make the decision, we need to using the data mining approach. There are many different data mining approach, as I just mentioned, like the association rules, clustering method, and other method is called data visualization. So data visualization is also an approach of the data mining. Okay, so the data visualization, just like as mentioned in the previous figures, we have the graphical representation. Okay, so this data visualization is very important. Okay, for example, when you look at these figures, you see that if we want to present the real world, okay, you can see that on the lower pictures, okay. So you present the real world by using the lower picture, but for different people, different people may would like to have different presentation. Like for example, if you are the customer, you would like just want to know the pathway of the streets. Okay, if you are an enterprise, you would like to know the distribution of the customers. Okay, if you are going to go to hiking, you may want to have some information on the landscape. So different people may want to have different geographical information. Okay, so that we need to apply the data visualization technology to present those data. Okay. Okay. I see that some one student asked me, what is the ERP? Okay, ERP is the Enterprise Resources Planning. Okay, so ERP is usually a system to manage a company with different resources. For example, human resources, if shipping, customer, there are many different things can be managed by the ERP system. Okay, so ERP is the Enterprise Resources Planning System that will be used to manage many different resources, including the human beings, your product, and so on. Okay, so you will see that the business intelligence visualization is very important, because you find that the data is very difficult to present something, but for the figure or a picture can tell you a lot of things more than using the words. So that data visualization is very important in the data mining. Okay, so when we using the different data mining software, one of the software is called real-time BI. Okay, so you can see the figures on the right hand side, lower right corner. So the real-time BI can display the dashboard just like on these figures, or we may also apply another software like the ClickSense. Okay, so I'll tell you how you can apply the ClickSense to do the data visualization during the lab session after the break. Okay, so you will learn how to apply this kinds of BI tools to do the data visualization in the lab session later. Okay, so besides the ClickSense, we also have another tools like the Microsoft Excel. It's also a kind of business intelligence approach. Okay, why? Because when you're using the Microsoft Excel, you can also plot the figures by using the Microsoft Excel. You can also using the pivot table and so on. But the Microsoft Excel is usually applied in the small organization. Okay, usually the Excel is applied in the small organization because it can only handle a limited number of information or data. If you need to handle a large amount of data, then you need to apply another software. Okay, just ClickSense will be a very famous software to do the data mining or data visualization. Okay, so this is what about for the business intelligence. Okay, it's just the introduction. Okay, that is, I just let you know some of the basic concepts on the business intelligence. And then how about the data mining? Okay, so when we talk about the data mining, first of all, I'd like to take a look on the figures on the left hand side. Okay, I would like to ask you a question. Can you count how many number of horses are there for the figures on the left-hand side? Okay, I give you 1 minute. Can you tell me how many horse you can find in the figures on the left-hand side? Okay, and you may let me know your answer. You may by pre, yeah. Some of the students tell me 5, and how about the other student? 7. Wow, 7. What, 8? Oh, wow. Okay, most of you can find 5 horses. Okay, let me count how many horses are there. Okay, 1, 2, 3, 4, 5. Okay, any others? Well, actually, I don't know the correct answer. If you can find 8, you may tell me the answer later. Okay, I can only find 5 or 6 here. 1, 2, 3, 4, 5. Okay, but I don't know the actual answer. Why? I ask this question. Okay, because when you're talking about the data mining, okay, we are talking about to finding some hidden pattern. So what is the hidden pattern? Hidden pattern. So you just like this figure, it's already the hidden pattern. Okay, it is very difficult for you to find the answer. Okay, if you can find the answer easily, this is not a hidden pattern because it is just the obvious answer. Okay, so remember, when we're talking about the data mining, we are going to talk about to find out some information from the hidden pattern. Okay, so this is called data mining. Okay, so another question on the right hand side. Okay, how many numbers of human or animals can you find on the figures on the right hand side? Well, student said there's 9. Okay, how about the others? Any more answer? Three. You can count including the animals and people. Yeah, 2 animals and 8 people. So many people. Okay, let me count how many animals and people in the figures on the right hand side. Okay, okay, this is 1. Okay, 2, and this is Nick, right? 3. Okay, 3 animal. Okay, how many people? 1, 2, 3, 4, 5. Right, there should have 5 people and 3 animals. Okay, total 8. Wow, one student said find 9. Okay, maybe you can tell me. Wow, I see that this is find 8 people. Wow, there are many people. Well, really? Okay, never mind. Okay, so again, the answer is very difficult to be able to find out from the figures on the right hand side, from these figures. Why? Because these are some so-called hidden patterns. So remember, what is data mining? Okay, after you play this game, you know what's data mining. So data mining is the task of uncovering the hidden information in the data. Okay, so what is the hidden information? Okay, like the non-trivial, implicit, previously unknown, potentially useful. So these are the core hidden information. That means if you can find out the answer very easily, that is not hidden information. Okay, remember, data mining is to extract those hidden patterns or information. Okay, so we, besides finding out the hidden information, usually we talk about finding those information from huge amounts of data. Huge amount of data. If there's only a small amount of data, okay, there's nothing to talk about because it's very easy for you to find out the answer. So when talk about the data mining, there are two major issues. One is the hidden pattern, another one is a huge amount of data. Okay. Okay. So when talk about the data mining, actually, we also have another term called knowledge discovery in database, KDD. So when you talk about the KDD, that means we're talking about the whole data mining process. Okay, but when talking about the data mining, which is only part of the KDD process. So please remember, don't confuse between KDD and DM. Okay, so these figures show the overview of the knowledge discovery in database process, KDD process. Okay, so when you take a look on the left-hand side, well, after you got some raw data, actually you need to mix a lot of process for data preparation. You need to do some data cleaning, selection, transformation. So these are called extraction, transformation, and loading process, ETL process. Okay, after you performed the data preparation, then you can conduct the data mining. So that's why data mining is only part of the process for the knowledge discovery in database. Okay, so we need, first of all, we need to have the data preparation, and then we need to do the data mining. After the data mining, then we can interpret or evaluate the results by the manager. And there are different types of data mining tasks. Okay, one is called predictive. Okay, that means you can make use of this approach to predict the result. And then another approach is called descriptive approach. So for the predictive approach, it's including the classification, regressions, and so on. And then for the descriptive approach, like the clustering, association rules, these are called descriptive approaches. Okay, you've learned the clustering association rules already. So let me talk about some more about the classification approach. Okay, so before we're talking about the classification approach, actually for the data mining, there are many different tasks for the data mining. First of all is the classification. We want to find out, define the classes based on the features of the data. Okay, and then we also have the clustering. So the clustering means that we want to identify a finite set of categories of data. Okay, and then we also have the regression. The regression is usually used to map the data to a real varied predictive variables. That means suppose you have some raw data, okay, and then you make use some linear regression or another regression approach to fit in these raw data, okay, so that we can predict the trend of all this data. And then we also have the dependency modeling. Okay, we want to find out a model between the dependence between different variables. We also have the deviation and change detection. We want to discover the most significant change in the data. We also finally also have the summarization. We want to find out the description on different set of data. Okay, there are many different tasks for the data mining. As mentioned, the classification is one of the important issue for the data mining. Okay, so for the classification, suppose you have to some of the raw data. Okay, you will need to think about some algorithm for the classification. For example, you need to find out some features for the classification. Okay, and then after you find out the features, then you can apply the algorithm for the classification, like you can using the rule-based reasoning, decision tree, or neural network. Okay, so as mentioned, for the classification, you may want to find out some classification items like or features. For example, you want to determine whether the cell is cancer cell. Okay, then you may want to identify it based on the color, the number of cells, the number of nuclear, and then you can find out the answer. Okay, so this approach is called rule-based reasoning approach or rule induction approach. Okay, so the rule induction approach is that it's just like if then approach. For example, if the color is light color and the tails is equals to 1 and the nucleus is equals to 1, then the answer is healthy cell. Okay, so this is the rule-based reasoning. We have if and then. Okay. Similarly, if the color is dark color and tails is number of tails is 2 and the number of nucleus is 2, then your answer is that the probability of the cell is cancer cell is 87%. Okay, so this is called rule-based reasoning or rule induction. And the other classification approach is like the decision trees approach, just like these figures. You can represent those items using the tree diagram, okay? And then you will get the answer very easily from the tree diagram. We'll talk about it in more details later. And then we also have another approach called neural network, okay? I'm sure most of you heard about the neural network from the AI, because nowadays most of the AI approach will make use of the neural network as the method for decision making. Okay, so by using the neural network, we can also find out the answer whether the nucleus is healthy or cancer cell. Okay, so this is that's all for my introduction of the business intelligence and data mining. Then now I would like to go to another PowerPoint slide, which is related to the first topic, rule-based reasoning. Okay, as I just mentioned, okay, there are 3 different classification approach: rule-based reasoning, uh, decision tree, and the neural network. So rule-based reasoning is the first topic we'd like to go through. Okay, maybe before we start to talk about another topic, maybe I would like to take a break, maybe 10 minutes break, to see if you have any question, because I'm difficult for me to ask you if you have any question online. Okay, because I cannot, we are not face-to-face teaching. So maybe we have 10 minutes break and then we back at 7:25. So if you have any questions, please leave me a message. Okay. Hello, we are back. Okay, so now you should able to see my PowerPoint, see my cursor, right? Okay, you should able to see my cursor now, right? Because I'm showing you my desktop. Okay, so first of all, we talk about the topic, which is about the rule-based reasoning. Okay, so before we start the rule-based reasoning, first of all, I'd like you to play this game, okay? River crossing game, okay? So on the right hand side of the river, you'll see that there are three missionaries and also three cannibals, okay? There are some constraint is that what we are going to do is that to make sure that all the missionaries and the cannibals will cross over to the river from the right hand side to the left hand side. So that's what is we are going for this game, okay? And so there are some constraint is that the missionaries can never be outnumbered by the cannibals on other side of the river. Otherwise, the missionaries will be killed. Okay. Or another constraint is that the boat can only carry up to two people on one side of a river, and it must be driven by either one missionaries or cannibal. So this is what you're going to do for this game. Okay. Now I would like to give you the link for this game. Okay. I'll test the. Okay. So you see my message on the chat box. Okay. I just send you the link of this game. Okay. Maybe I'll give you 5 minutes to see whether you can solve this problem. Okay. You play this game for and then see whether you can solve this problem. Okay. I'll give you 5 minutes. Okay. Once you complete the game, please let me know and then tell me the answer on the chat box on the right hand side. Okay. Once you complete, please let me know to see who is the faster to complete this game. Okay. Okay. I think most of you has already finished. Okay. Um, Maybe I will try to see whether I can solve this problem. Okay. Let's see if you got the answer. Okay. Okay. So this is the answer. Okay, so remember the answer because later after finish this lesson, you need to complete the first assignment. So this question is your assignment. Okay, but how to complete this question? I'll tell you that what kind of approach you need to apply later. Okay, actually, in this lecture, I'll talk about the rule-based reasoning approach. That means in your assignment, you need to complete this game by using the rule-based reasoning approach. Okay, so what is the rule-based reasoning? Okay, the rule-based reasoning is that it just makes, but it's just to solving the problem by using the if then rules. It seems quite simple, okay? But actually, this rule-based reasoning has been developed for many years and applied in the artificial intelligence system in many years ago. So this is a very important uh, approach for many years already. Okay, and then we'll talk about some of the control strategy to solve the problem. Actually, in order to solve the problem, we need to using the state space approach. There are many different strategy like the depth search, breadth search, and we'll talk about what are the difference between these kinds of state space approach. And then we will talk about the reasoning strategy. We have the forward training strategy. We also have the backward training strategy. And then finally we will demonstrate the rule-based reasoning by using the water jar problem. Okay. I forgot to show you the mouse pointer. Okay. Let me show you the laser pointer. Okay. So we talk about the intelligence. So what is the intelligence? Okay. When we talk about the intelligence, remember that intelligence is talk about the ability to think, understand, and learning. So these are some of the key issues when you talk about the intelligence. Okay, so nowadays we talk about the artificial intelligence. So what is the artificial intelligence? Actually, the artificial intelligence means that how can we mimic the human behaviors by using the machines. Okay, that means the machine need to mimic the human behavior. So what are the important human behavior? Is talk about thinking, understanding, and learning. So we talk about thinking is talking about the ability to considering a problem or create any idea or solving a problem. So in order to solve a problem, we may need to have some reasoning strategy. Okay, and we talk about what kind of reasoning strategy. As just mentioned, we will need to make use of the space-based approach. We are using the depth search and breadth search. So these are so-called reasoning strategy, and I'll tell you in more details later. Okay, so when you talk about the rule-based reasoning, so actually you will see the rule-based approach in many situations in daily life. For example, for somebody crossing the road, when you see the traffic light, if the traffic light is green, then you can cross the road. But if the traffic light is red, then you stop. So you see that you can see many these kinds of rule-based approach in the daily life. So if the traffic light is green, so this is the if situation. And then if the traffic light is green, then you can cross the road. So you will see that in many real life situations, we will apply the if-then structure in many different daily life situations. Okay, by using this rule-based approach, we can solve a lot of problems already. Okay, so that the rules is a knowledge representation technique. Okay, we can using the if-then structure to define the rules, and then we have to apply the rules to solving a problem, and the rules must be easy to create and be easy to understand. Okay, so for the if-then rule structure, there are two major parts. The first part is the if part. If part is called the condition part. Okay, and then second part is the then part. The then part is the consequence part. Okay, so we can representing if condition is if whether it satisfies a certain condition. Then if it is satisfied certain condition, then what is the consequence? So this is the representation of the if-then rules. Actually, we can also add multiple conditions in the if-then structure. For example, if it satisfies the condition 1 and condition 2 and condition 3 and so on, then the consequence is something. Or you can using the or disjunction, okay, to add into the if-then structure. Okay, we have the if condition 1 or condition 2 or condition 3 and so on, then it will happen something. So this is what we can add in the if-then rules. We can add the and conjunction or the disjunction in the structure. So in the if-then rule structure, you will see that we first in the first part, if part, we have the linguistic object. For example, let me show you an object, an example. Okay. Okay. So the first part is if part. Okay. So if, for example, the BMI index. Okay. I'll write it BMI index. Okay. BMI index. So this part is an object, or we call linguistic object. Okay, this is BMI, and then we will add an operator. For example, if the BMI is larger than 20. Okay, so the BMI is the linguistic object. Larger is the operator, and finally we have a 20 is the value. If the BMI index is larger than 20, then the BMI larger than 20 is the condition, right? Then what's happened? Okay, too fat. Okay, then you are too fat, or we so simply say fat. Okay. So if the BMI index is larger than 20, so BMI is the linguistic object, larger is the operator, 20 is the value. So the consequence is fat or overweight and so on. Okay, actually you can add more condition. For example, if the BMI index is larger than 20 and if you are a boy, okay, then you are fat. Okay, so actually you can add some more condition. Okay, so this is called if-then rules. Okay, This is another example. Okay, so if the age of the customer is the object, the smaller is the operator, 80 is the value. If the age of the customer is less than 80, and then we add one more condition, is the cash withdrawal is larger than 1,000. Okay, then signature of the parent is required. Okay. Go back to part one. Okay, then signature of the parent is required. So this is the if then rules example, right? Okay, so the rules can actually representing the relationship, the recommendation, directive, strategy, and heuristic. There are many different rules can represent by using the rule-based reasoning approach. Okay, for example, if we're talking about the relationship, like if the fuel tank is empty, then the car is dead. You will see the relationship between the fuel tank and the car. Okay, and another representation is the recommendation. Okay, if the season is autumn and the sky is cloudy and the forecast is drizzly, and then the advice is to take an umbrella, it may not happen. It's just a recommendation. Okay, so you will see the application of the rule-based approach, or it can be a kind of directive. If the car is dead and the fuel tank is empty, then what is the action? Is to refuel the car. So it's just a direction. It just tell you the direction, what you need to do, how you solve the problem. Okay. And then another approach is called strategy approach. Okay. If the car is dead, then the action is to check the fuel tank. Okay, check is whether the fuel tank is empty or not. Okay, after you step one is complete, then you have another condition is that, and the fuel tank is full, then you need to check whether the battery is full or not. Okay, so this is a kind of strategy. Okay, so that why we call that the rule-based reasoning was applied in many years ago for the artificial intelligence application, because the rule-based reasoning approach can have many different kinds of representation or helping the human being to solving the problem by using these kinds of rule-based reasoning approach. Okay, and then finally we have the heuristic approach. If the spill is liquid and the spill pH value is more than 6 and the spill bounce smell is weakened, and then we'll call this kind of material is acid. Okay, this is another heuristic approach. So you can see the rule-based reasoning can be used as a kind of approach to solving the problem. Okay, so actually when we're talking about the rule-based reasoning approach, okay, we need to have talk about the expert system. Okay, as mentioned, artificial intelligence in many years ago is to apply the rule-based reasoning. At that time, we call this class of AI system is the expert system. Okay, and the expert system is to apply this rule-based reasoning to solving the human problem. Okay, so therefore, you can imagine that if you are the computer, how can you communicate with the human beings and then solving the problems? Okay, so that the expert system will consist of these different module. Okay, so first of all, we have some database. So the database are the facts. Okay, and then second database is called knowledge-based database. So this knowledge-based database will consist of many if-then rules. Okay, and then based on this knowledge-based and the fact database, we'll make use
Professor,
of right.
we cannot see the PowerPoint.
You can see the PowerPoint.
Yes.
Oh, okay.
Thank you. I still cannot see.
Is it okay right now?
I can see your screen, but still do not have any PowerPoint.
Okay, is it okay?
No. Maybe I refresh the screen and try.
It's okay now.
It's okay now. It's okay now. Yeah.
Okay, thank you. Okay. Okay. So sorry for that. Okay, please interrupt me if there's any problem. Okay. So we talk about the rule-based reasoning. Okay. As just mentioned, at many years ago we have talking about the expert system. Okay. So the expert system will apply the rule-based reasoning approach to answer the question from the human. Okay, so the expert system will consist of these different modules. So we have the knowledge-based module as well as the database module. Okay, so the database module contains some of the facts. Okay, and then for the knowledge-based module will consist some of the rules, if then rules. Okay, and then based on this knowledge-based database and the fact database, we can make use of the inference engine to inference some of the answers. Okay, based on the questions from the humans. Okay, and then we have the explanation facility as the middle software to communicate between the inference engine as the with the user, and then the users, the human being, can input some of the question by using the user interface. And then based on the explanation facility as a middleware, and then finally we have the inference engine. The inference engine is used to solving the answer of the human being based on the knowledge-based database and the fact database. So, so what are the basic structure of the rule-based expert system? As mentioned before, we have the knowledge-based database. So the knowledge-based database consists a set of rules. So this is very important. Okay, as just mentioned, based on this if-then rule structure, you will able to answer the questions from the human beings. Okay, so if the condition part of a rule is satisfied, we call this rule is set to be valid. For example, if I said if the BMI index is larger than 20, okay, if it's satisfied this condition, then we set the rules is fired. Okay, and then another database is a set of fast database. So because when the computer need to identify whether the condition can be fired, they need to have some fundamental knowledge. So these are the facts database. And then we have the inference engine. So the inference engine is used to carry out some of the reasoning. We have the forward training or the backward training. Okay, and then we will link the rules given the knowledge base with the facts provided in the database. Okay, so that the inference engine will link to the knowledge database and the facts database, and then we will carry out some of the reasoning to answer the questions from the people. Okay, and then finally we have the explanation facilities and user interface to talk with the or communicate with the users in the expert system. Okay, so what is the difference between the forward and backward training? For example, as mentioned, okay, we have two different database, the fact database and the knowledge-based database. Okay, so suppose that we know some facts is A, B, C, D, E are true. Okay, and then we have some rules like if Y and D are true, then Z will also be true. Okay, And then another rule is that if X and B and E are true, then Y is also true. Okay, and so on. So there are many different rules. Okay, so if we know that A, B, D, and E are true, we want to see whether Z is also true. Okay, then we need to apply this fact as well as this knowledge. Okay, then this is called forward training. Okay, that means if we know that A, B, D, E are known, and then we want to prove whether Z is also true, then by using this direction, then it is called forward training. Okay, so A imply A is true, then X is also true. So that A imply X. Okay, if X, B, and E are true, then Y is also true. Then X, B, E true and imply Y is also true. And Y and D is true, then imply Z is also true. So you got the answer. So that is called forward training. But in other way is that if A, B, D, E are true, and you want to prove whether Z is true, then you can come from backward side. Okay, that is called backward training. Okay, I'll show you more examples later. So you will see that there are some advantages of using the rule-based system. Okay, first of all, it's uniform structure. Okay, you can see it's very formal. Okay, every rule is in a uniform if-then structure. Okay, and then each rule is independent piece of knowledge. So each rules are independent to each other. Okay, and then secondly, we can dealing with incomplete and uncertain knowledge as well. Okay, for example, we can have some certainty factor. But there are some disadvantages of the rule-based system. Okay, for example, the opaque relationship between rules is that it may be difficult to observe how the individual rules will serve the overall strategy. Okay, because each rules are quite independent to each other. So that means it's very complicated to see how we can come up with the overall strategy. Okay, this is one of the disadvantages. Another is the disadvantage is very important is that the expert system do not have an ability to learn from the experience. When we're talking about the AI, okay, I know most of you will know that the AI will learn something based on the data. If we have more data, we will have a better result. This is so-called AI nowadays. But many years ago, when you're talking about the AI, we will apply the expert system. But one of the major disadvantages of using this expert system is that it do not have an ability to learn from the experience. There's no learning at all for the expert system. This is the major problems for the AI expert system in many years ago. Okay, so when we're talking about the AI, okay, I know that most of you heard about artificial intelligence, machine learning, and the deep learning. Okay, so do you know what is the difference between all of them? Okay, actually, nowadays the AI has been developed very fast nowadays. There are two major reasons. First of all is that nowadays the AI can learn from the experience, can learn from the data. If you have more and more data, it will become more and more accurate. So this is one major issue that the AI has been developed faster and faster than many years ago. Okay, and then second important reason is that okay, the computation power is much faster than many years ago. Okay, that's why we AI artificial intelligence has been growing much faster than many years ago. But actually, AI has been developed for many years already. But at that time, we are talking about using the expert system. Okay, but why the AI nowadays has the learning ability? Because that we have applied another terms called machine learning and the deep learning. Actually, artificial intelligence is that a computer or the program that can mimic the behavior of the human. Then we call this is AI. So that AI is a very large set of compared with the machine learning and the deep learning. And then machine learning is just the subset of the artificial intelligence, and the deep learning is another subset for the machine learning. So that is the difference between the AI, ML, and DL. Okay, so I'd like to show you some pictures. Okay, when we talk about the AI, okay, I'd like to ask you whether you can identify which pictures are the cats, which pictures are dogs. Okay, I think it is not difficult for you to identify which pictures are dogs, which pictures are cats. Okay, but how can you teach the computer to identify cats and dogs? Okay, how can you teach the computer? Okay, anyone have any suggestions? You may put your answer in the chat box. Okay, what kind of features you will suggest to identify cats and dogs? Okay. Okay, you can show your answer on the chat box. Okay, what features to identify cats and dogs? Can you suggest some of the answer? Okay, dog has long nose, cat has short nose. Any other suggestions? Okay, if you're a human being, when you take a look on this picture, you can identify it very easily. Oh, barking a lot. Okay, that's good suggestion. Voice, yes. Okay, any other suggestions? Okay, no more suggestions. Okay, maybe I go back to our PowerPoint slide. Distance between eyes and from the eyes to the nose. Wow, this is good. Okay, maybe I go back to the PowerPoint slides. Okay, so how can you identify dogs and cats? Maybe, okay, to listen to their voice. Okay, and many years ago, we are using the expert system. We are using the rule-based reasoning. Okay, we check if the dog is barking, then the answer is dog. Okay, if meow, then if the voice is meow, and then it should be the cat, right? And another way is to check the pattern. Okay, the body pattern. Okay, if the body has pattern, then it should be a cat, but with some certainty factor. So how about the machine learning and the deep learning? So what are the difference? Okay, so you see that, okay, we need, when you are using the expert system, okay, we just tell the computer if barking, then it's dog, if the body has pattern, it's cat, and so on. This is the if then rules, but they cannot improve if we have more data. Okay, they just follow the rules. Okay, but when we're talking about the machine learning, we need to apply another approach. We cannot using the rule-based reasoning, if then rules, we need to make use of the neural network for learning. Okay, that is why the neural network is important nowadays. Okay, because the neural network has the ability to learn. Okay, but when talking about the machine learning, okay, it means that only part of them is learning, and then another part still we need the manual input. Okay, is that what are the features? Okay, how to identify cats and dogs? Okay. As mentioned, we can make use of the voice. Okay, you can see the pattern. You can also take a look on the distance between the eyes and the nose, and the length of the nose, and so on. So these are the manual input features. Okay, this is called machine learning. The machine learning that we still need some manual input feature. Okay, and then how to classify they are cats or dogs, then we need to make use of the neural network for learning. Okay, that is called machine learning. But for the deep learning, it's totally different. We just need to give them input. Okay, the machine will able to learn not only the feature, it can also able to learn how to classify what are dogs and what are the cats. Okay, you don't need any human input anymore. Okay, so this is called deep learning. So this is the difference between AI, ML, and DL. Okay, so finally, so we have this picture. So what is the answer from the machine learning and the deep learning? You know, is it cat, dog, or a pig? Okay, so the answer is that either cat or either dog. Okay, the computer cannot show you the answer pig, because okay, we didn't tell the computer how to what is cat and what is dog yet. Okay, later on we'll cover it in more details in the later lecture. Okay, we'll talk about the neural network in more details in the next lecture. Okay, so but now we know what are the difference between the AI, ML, and DL. We also know what is the major disadvantages of the if then rules, the rule-based reasoning is that the rule-based reasoning do not have any ability to learn. Okay, this is the major issue. Okay, and then we go back to the rule-based reasoning again. Okay, because this lecture we just only focus on the express system. We only focusing on the rule-based reasoning. Okay, so when we talk about the rule-based reasoning or the AI problem-solving ability, we have two issues. First of all is to how to represent the knowledge, and secondly is how to reason with this knowledge to find out the answer. Okay, so how to represent the knowledge and how to find out the answer. So in order to find out the answer, we call reasoning. Okay, or reason. Okay, and then before we find out the answer, first of all, we need to represent the knowledge first. So how can we represent the knowledge? One approach is called state-based approach. Okay, what is called state-based approach? Okay, so for the state-based approach, which will consist of the initial state as well as the goal state. For example, let me show you an example. Okay, suppose we have two bottles. Okay, this is bottle 1. Okay, and then we have another bottle. Okay, this is quite difficult to draw the figures using the mouse. Okay, we have only 2 bottles. Okay, and suppose at the beginning there's no water on both of these bottles. Okay, so that we can using the state-based approach. Okay, state-based approach is represented by bracket X and Y. Okay, close the bracket. X means that the water inside the bottle 1, and the Y means the amount of water in the bottle 2. Okay, so for the state, this is the state space representation for these two bottles. That means we can make use of this state space approach to represent this question mathematically. Okay, remember, in order to represent the knowledge in the computer, you have to make use of the mathematical equations. Okay, so we're using the space approach, x and y to represent the amount of water in bottle 1 and bottle 2. Okay, so for the initial state is that there's no water on both bottle. Okay, the amount of water is 0 liter for bottle 1 and 0 liter for bottle 2. And then what is our goal is that, okay, we want to fill up bottle 1 with 2 liter of water and bottle Y with 1 liter of water. Okay, so this is the goal state. Okay, and then in order to come up the answer for this question, okay, we need to set a set of rules. Okay, we'll show you in more detailed example later. Okay, and then secondly, we also need to have a control strategy. Okay, I'll tell you what is the control strategy. Okay, so what is the control strategy? As just mentioned, we have the state space representation. We're using the bracket x and y to represent the amount of water in bottle 1 and amount of water in bottle 2. Okay, and then we need to have the control strategy to solving this problem. We have two different approach. One is called depth first search approach. Another one is the breadth first search approach. Okay. Before I talk about in more details what are the difference between the depth first search approach and breadth first search approach, I'd like to stop for 10 minutes to see if you have any question first. Okay, you may let me know in the chat box if you have any question. Okay, and then we'll come back in around 10 minutes later. Right? Okay. Okay, we're back to talk about the control strategy. I see the student have many questions, but maybe we can still have time to answer the question after this lesson. Okay. So we talk about the control strategy. Okay. So when you talk about the control strategy, we have the different method like the depth first search and breadth first search. So what are the difference? So for the depth first search, let me show you the figures. Okay. Suppose A is the initial state, and then we would like to find out the answer. So how you find out the answer? Then you may see whether if we want to see if you know that A is true, and then we will find that okay after we know A is true, then we have the other options like B, C, and D, and then if we have the option B, we also have a E, F, G, H, and so on. Okay, so for the depth first search, in also to find out the answer, we'll start searching the answer starting from the left to right. Okay, from left to right, and then we go deftly in along this direction first. Okay, that means we search the answer from A, B, E. Okay, if there's no further path, then we go back to B and then go to F. Okay, if we still cannot find the answer, we go back to A and then go to C, G, I, and then J, and then H, and D, and so on. So remember, for the depth first search is from the left to right. We go through the depth in the left hand side first. Okay. So you see the depth first search is that a left to right depth first search moves vertically deeper in the search space first. Okay. If we cannot find the answer, we go to the right hand side and so on. Okay, so the first stretch is different. We want to find out the answer by moving horizontally through the searching space. Okay, let's see these figures. Okay, that means if we want to find out the answer, okay, we'll start from A, B, C, D. If no answer, we search E, F, G, H. If no answer, I, J, and so on. Okay, you see we go through in the in this direction, breadth direction. Okay, get find out the answer. Okay, so let's take a look on the example. Okay, for example, this is the initial state, and this is the goal state. Okay, we want to achieve this answer 1, 2, 3, 4, 5, 6, 7, 8. Okay, and the initial state is at 1, 4, 3, 6, 2, 8, 5, 7. Okay, so actually we can representing this question by using the state space representation. Okay, remember the state space representation is the bracket, and the initial state is 1, 4, 3, 7, and then empty. Okay, E means this one empty. 6, 5, 8, and 2. Okay, this is the initial state. Okay, and then the goal state is that we want to find out this answer. Okay, the answer is 1, 2. Oh, sorry. Okay. 1, 2, 3, 8, empty, and then 4, 7, 6, and 5. Okay, so this is the goal state. Okay, so we would like to find out the answer from the initial state to the goal state. So how to search the answer? Okay, so actually from the initial state, this empty block can move upward, left direction, right direction, and down direction, so that we have 4 possible outcomes. Okay, and then for the outcome on the left hand side, this block can also move in the left direction or right direction, so that we have another two outcomes. Okay, so that we can apply the breadth search to find out the answer. Okay, so you can see the sequence for searching the answer for the breadth search. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and so on. Okay, after 46 steps, we got the answer. Okay, this is the answer. Okay, but for the depth first search, okay, we start from left to right. We start from left and then moving vertically. Okay, so we start from 1, 2, 3, 4, 5, 6, 7. Okay, when we go to the 6 steps, well, okay, at the block is at this corner. Okay, we don't have any further answer. Okay, it stopped already. It's stuck already. Okay, that means we need to go back and then moving to the other directions. Okay. Okay, there's no further answer. Then we go to step 8, 9, 10, 11, and so on. Okay, from left vertically and then to right. Okay, finally we got the answer in the 31 step. Okay, so can you see the difference between the depth first search and breadth first search? Okay, so here this table summarize the advantages and the disadvantages of the depth first search and the breadth first search approach. For the depth first search approach, some of the advantages is that it is easy to implement. It requires a relatively small memory for storing the state space. Why? Because for the depth first search approach, you can see that, okay, when we find the answer in this direction, if we don't have any answer, then we can forgot those memory and then moving in this direction. Okay, no answer, then we got forget those memory and then moving another direction. So that it requires less memory state, memory compare with the breadth first search. For the breadth first search, if you want to find out the answer, okay, you need to remember all this state space. Finally, after you got the answer, well, you have to come back to find out the optimal answer. So this is the advantage is for the depth first search is that it requires small memory. For the breadth first search, it requires more memory. That is one of the major disadvantages of the breadth first search. But for the breadth first search, you can guarantee that you will find a solution. And most likely it will be an optimal solution. But for the depth first search, sometimes you will fail to get the solution. And sometimes the solution may not be the best answer as well. Okay, so that there are some advantages for the depth first search as well as for the breadth first search. So this is the control strategy for the space-based approach. And then another is the reasoning strategy. As mentioned before, in order to find out the answer, you can start from the initial state to the goal state. So this is called forward training. Or in the other direction is that you start from the goal state back to the initial state to see whether the answer is true or not. Then this is called backward training. So when we apply the forward training is that when we wish to determine all possible outcomes, then you will apply the forward training. But if you want to find out the answer, okay, or you have a specific goal to be satisfied, then you may apply the backward training. Okay, so there are two different approaches you may apply based on different situations. So for the forward training approach, it is a kind of data-driven reasoning. If the condition has been met, or we call the rules is fired, then the consequence is that the consequence of the rule is add to the current state of the knowledge, and then we proceed to the other state. Okay, so maybe it's very difficult for you to understand for this. So we show you a good example to see how we can solving the problem by using the depth first search and breadth first search, and also using the further training. Okay, so we talk about the water jar problem. Okay, suppose we have two jars. Okay, one is small, another one is a big one. For the small one, it can hold 3 gallons of water. For the big one, it can hold 4 gallons of water. But remember that both jars do not have any measurement lines. Okay, so that we can never determine the exact amount of water in either jar. Okay, so this is the difficulty. Now, what we are going to do is that we want to, okay, so initially we have no water on both jars, and then we want to find out that we want to fill 2 gallons of water in the 4-gallon jar. So this is a question. Okay. So the question is that we want to place 2 gallons of water into the 4-gallon jar. Remember, there's no way to determine the exact amount of water in either jar. So that is the difficulties of this question. So in order to answer this question, there are several steps. So for the first step is that we need to determine a state space representation for this problem. Okay, remember the state space representation. Okay, we can make use of the bracket, and x representing the amount of water in the 4-gallon jar, and then y representing the amount of water in a 3-gallon jar. So this is the state space representation, bracket x and y. Okay, this is the state space representation. And then by using this state space representation, we can have the initial problem state that both 4-gallon and 3-gallon jar has no water. That means bracket 0 and 0. So this is the initial problem state, no water in both jars. And then the goal is that we want to fill in 2 gallons of water in the 4-gallon jar. So that's 2. And then question mark. Question mark means this, we don't care how many waters in the 3-gallon jar. Okay, we just want to make sure that there are 2 gallons of water in the 4-gallon jar. Okay, so this is first of all, we need to represent this question mathematically using the state space representation. And then secondly, in order to solve this problem, we need to set a set of rules. Okay, so the set of rules, as we have mentioned, we have to make use of this if and then if then condition. Okay, rule-based reasoning to set these kinds of rules. Okay, remember we just like to have the AI expert system. We need to set a lot of rules in order to ensure the computer can solve this problem. Okay, now so this table shows these kinds of rule-based reasoning statement. So if the in this table on the left hand side, this is the action. This means the final action. The middle column means the required condition, and the right one is the resultant state. Okay, remember that when we're talking about the rule-based reasoning, we need to have the if then condition. Okay, we go back to the rule-based reasoning. Okay, now you can see that for the if then rules, they consist of 2 parts. One is the if part. If part is the condition, then part is the conclusion or the action. Now we go back to these 2 columns. Okay, so this is the condition. This is the if part, and this column is the action part. That means if the 4-gallon jar is not full, then we fill the 4-gallon jar. Finally, the resultant state will become 4 and y. So this is the state space representation after implement this action, and then this is the result of the state space representation. Okay. So we need to set a lot of rules. Okay, if the 4-gallon jar is not full, then we fill in the 4-gallon jar. If the 3-gallon jar is not full, we fill in the 3-gallon jar, and the result state is that. If the 4-gallon jar is not empty, we need to empty the 4-gallon jar onto the ground so that the resultant state will be 0 and y and so on. So we need to set a lot of rules and action. Okay, so this is the second step. Okay, remember, in order to solve the problem, so okay, later you need to do the assignment. So in order to do assignment, first step is to representing your problem by using the space approach. Okay, just like this one, write down the initial problem state and the goal state. Okay, first this is the first step. Second step is need to set a set of rules by using this table. If condition, then what is the action and what is the resulting stage? Okay, this is the second step. After you set a set of rules, then the first step is to think about what control strategy you want to implement. So remember, I just mentioned that there are two strategy, state space control strategy. One is the depth first search approach, another one is the breadth first search approach. Okay, you can using either method to solving this approach. So in this example, I would like to using the depth first search. Okay, so we start from the initial state 0, 0. Okay. Okay, so for the initial state step 1, okay, you find that, okay, because both jar is not full, okay, you can either, okay, satisfy rule 1 or rule 2. Okay, you will see you have already complete this table. You can search for all of these rules and you'll find that only the first and second rules satisfy this condition. Okay, so that for the rule 1, okay, the 4-gallon jar is not full, then your action is to fill in the 4-gallon jar, and the resultant state will become 4y. So that initial state is 0 and 0. It only satisfies rule 1 or rule 2. For the rule 1, you fill in the 4-gallon jar so that it becomes 4, 0. And then for the rule 2, you fill in the 3-gallon jar so that you will become 0 and 3. Okay, so this is the first step to solving this problem. Okay, in the second step, as mentioned, we are going to using the depth first search to solve the problem. That means you need to go deeper under the rule 1 first on the left hand side. Okay, so on the left hand side, let's see on the left hand side, 4, 0. Okay, for the rule 4, 0, you need to see which rule will satisfy this condition. Okay, and you'll find that, okay, only rule 2 and rule 6 will satisfy this condition. Okay, because for the rule 6, the 3-gallon jar is 0. That means the 3-gallon jar is not full. Okay, so what you need to do is to fill in the 3-gallon jar. Okay, so that we go to rule 2, fill in the 3-gallon jar so that the state 4, 0 will become 4 and 3. Okay, it can also satisfy rule 6. Okay, for the rule 6, that means the condition is that the total amount of water in both jars is larger than 3, and the 4-gallon jar is not empty. So the total amount larger than 3, and the 4-gallon jar is not empty. That is satisfy this one. Okay, then we go to rule 6. Okay, for the rule 6, we pour water from the 4-gallon jar into the 3-gallon jar until the 3-gallon jar is full, so that the resultant state will become 1 and 3. Okay, that satisfies rule 6. Okay, And then we need to go deeper on the left-hand side first, because as mentioned, we are going to using the depth first search approach. Okay, so for the depth first search approach, we check all these rules. Okay, and then we find that, okay, only condition 3 and 4 are met. Okay, but when we apply the condition 3 and condition 4, you find that we'll go back to this state and this state. Okay, for example, if you apply the rule 3, okay, rule 3, if the foreground jar is not empty, so it satisfies this one, then we empty the foreground jar. Okay, after you empty the foreground jar, it will become 0 and 3. That means you go back to this state. Okay, this is not our answer because it look back to the original state. Okay, so that we will not go further because it's not correct. Okay, because it going back. Okay, and then another condition match to this situation is that the figure jar is not empty. Okay, we will empty the figure jar. Okay, when we empty the figure jar, okay, we go back to this condition again, so that we will go back to the original condition. So therefore, in this situation, we will not apply the condition 3 and condition 4. Okay, so there's no more answer in this direction. So we finish on the left hand side, we go on the right hand side. Okay, go deeper in this direction. Okay, when we go deeper in this direction, okay, we find that, oh, this one satisfies the rule number 4. Okay, and then if the free jar is not empty, we would like to empty the free jar onto the ground. So that means the file state will become 1, 0, and so on. Okay, 1, 0, and another step is step 4. We specify this one, step 5, and step 6, and then finally we reach the final answer. The resulting state is that, oh, resulting state is 2 and 3. If we representing the goal state, because our goal state is that we just want to have the 2 gallons water in the foreground jar. Okay, so we reach the final answer. So based on this state-based approach, we finally got the answer. We write down the step again. We apply rule 1, 3 in the foreground jar, apply rule 6, and so on. And then finally, we reach the answer. Okay. So in this example, you see that we are using the breadth first search, depth first search. We go deeper into the answer. Okay, and we like to also we have applied the forward changing approach. Okay, as mentioned before, besides the forward changing, we also have another way is called backward changing. The backward changing is usually applied for the growth driven reasoning. Okay, we would like to suppose we have the questions. We would like to prove whether the answer is correct or not. Then we will apply the backward changing approach. Okay, so this is another example. So how we can apply the backward changing to solving the problem. Okay, now again, remember that in the expert system, there are 2 databases. One is a fact database. We store all the facts like that. We know A is true, C is true. Okay, another is the rule database. Okay, we store all the production rules. For example, if A is true, then B is true. If C and D is true, then X is true, and so on. So another database show all the rules. Okay, remember in the express system we have this database and the fact database. Okay, so we know that the facts A and C are initially true, and then our task is to prove that G is also true. Okay, So in this way, you will see that G is true is our goal. Okay, we would want to prove whether G is true or not. Okay, then in this direction is called backward chaining. Okay, now for this method, first of all, you need to check the set of that to determine if G is initially true. Okay, so based on this table, you find that okay, if G is true, then X and Y must also be true. Okay, so if G is true, X and Y is also true. So this symbol representing the AND condition. So if there's no this symbol, that means OR condition. Okay, and we know that if G is true, X and Y must also be true. And then this is the backward chaining direction, but we need to make use of the one of the control strategy. Again, we would like to using the depth first search approach so that we moving that vertically in the left direction first. Okay, so and we know that we want to prove G is true or not, and you need to choose whether X and Y are true. So in order to prove Y is true or not, okay, you check the rules. Oh, you find that okay, if Y is true, then W must be true. So we have W here. As mentioned, we want to make use of depth first search. Okay, now, oh, if W is true, if we have any further protection rules, there's no more protection rules. When we check the facts, there's no facts. Okay, that means this is the dead end. Okay, this is the, in this case, we have to grow in the other direction. Okay, if Y is true, W is true, but we don't have any further answer, then we check another rules. Oh, we find that if Y is true, B should be true. Okay, that means if we want to have the Y is true, then W or B must be true. Okay, so W is the end. Then we check the whether B is true or not. Okay, so if A is true, then B is also true. Okay, that means we can go further in this direction. If B is true, then A should be true. Okay, and then for this end, you find that, oh, based on our fact database, we already know that A is true. That means A is true. A is true, then B is true, B is true, Y is true. Okay, Y is true. Whether G is true or not, we also need to check whether X is true or not. Okay, now we need to prove whether X is true to conclude the initial goal. Okay, so based on our protection rules, we know that if C is true, then C and D need to be true. Okay, C and D need to be true. Okay, based on the knowing fact is that we know C is true. Okay, how about D? We don't have any protection rules anymore, and we don't have any fact to tell that D is true. That means D may not be true. In this case, X may not be true. X may not be true, then G may not be true. So we got the final answer. Okay. W is not true, D is not true, D is not true, X is not true, X is not true, G is not true. So we have the conclusion is that G cannot be proved to be true. Okay, so this is called backward changing approach. Okay, so remember when you apply the rule-based reasoning, first of all, you need to representing the question using the state space representation. Secondly, you need to think about the control strategy, depth first search or back first search. And then thirdly, you need to using forward training or backward training approach. Okay, so that's all for my PowerPoint presentation today. Do you have any questions? Maybe before you ask the question, first of all, as I mentioned before, you need to complete an assignment. Okay. Now let me show you that. Where can you download the assignment? Okay. You will able to download the question of the assignment from the Blackboard. Okay. You can log into your Blackboard and then click into your class. And then on the left-hand side, you select the content. And I've already posted some of the information on the Blackboard. Okay, so there's some teaching materials for today's lesson, and also the assignment for this lesson. Okay, so when you select the assignment folder, you will see that the first one is about the rule-based reasoning, and then you can click to download the question of this assignment. Okay, so the deadline to submit this assignment is on Friday. On Friday. Okay, Valentine's Day. Okay, so you have to submit the assignment on this Friday, 11:59 p.m. Okay, and how you submit the assignment? You just need to click to this link and then upload your assignment to the Blackboard. Okay, and then submit the answer. Okay, so what is your question for this assignment? Okay, let me show you the question for this assignment. Okay, after you download the question, you see the question for this assignment. So, as I mentioned earlier in this lesson, what you need to do is to answer these questions. Okay, you just play the game, and then I see that some of you has already completed the games. Okay, so in this assignment, what you're going to do is to finish this game. Okay, by using the state-based representation, state-based approach. Okay. You can download the assignment from the Blackboard. Okay, and then after you complete the assignment, okay, just click this link and then upload the assignment to the Blackboard for the submission. Remember the deadline for submitting this assignment is on this Friday. Okay, so that's it for this lecture. Okay, so do you have any questions? Okay, if you have any questions, you can leave me a message. Okay. Otherwise, you can leave earlier because it's already done, because it's just the first lesson. So if you have any question, you can leave me the message. You can also try to complete the assignment, or you can complete the assignment before this Friday.